Hey guys, Mr. Milton here. Today we are going to talk about law of sines. At the end of this video, you should be able to determine when law of sines is appropriate to use, and you should be able to use the law of sines to find missing angle measures and side lengths. Okay. So looking at this triangle up here, it's a little bit different from what we've been looking at up to this point in this chapter, because we're not able to use our trig to solve this problem. And the reason we're not able to is because it is not a right triangle. Okay, remember that with the trig that we've talked about so far, we've had to use a right triangle. Okay, and most triangles aren't right triangles. I'll say a lot of triangles at least aren't right triangles. And so the law of sines will help us to find all the missing pieces of this triangle, and really any triangle, because it works for any triangle, not just right triangles. Okay, so the law of sines is here. A over sine A equals B over sine B equals C over sine C. Okay, notice that the side lengths are shown using lowercase letters, and the angles are using capital letters. Okay. Now, I'm going to show you a proof of why this works, just because you will not need to recreate this or anything like that, but I just want you to understand that it works for a reason. Okay? So, what we're going to do first, I'm going to make this a right triangle. I'm going to make some right triangles, let's say that. Okay? So, right triangle here. I'm going to call this side H. Alright? And so we can go sine of A, okay, with this left right triangle. Sine of A equals opposite over hypotenuse, H over B. In this triangle here, also a right triangle now, okay, we can say that sine of B opposite over hypotenuse, H over A. Okay, in this side, I'm going to kind of deal with these separately. We'll multiply both sides by B, and I get H equals B sine of A, B times sine of A. And on this side, I'm going to multiply by A, and I get H equals A times sine B. Okay. So you should notice, hey, this H is the same H, right? H equals B sine A, H equals A sine B. So we can say that actually B times sine A is the same as A times sine B. Okay. From here, what I'm going to do is I'm going to divide both sides by sine A. Okay, on the left side, that'll cancel out, and we get B equals A sine B over sine A. And then my final step to this proof is I'm going to multiply both sides by 1 over sine B. Okay, essentially dividing it. I just didn't want to make two fractions there. Okay, and that cancels out the sine B. So on our right side here, we're left with A over sine A. And on our left side, we're left with B over sine B. Okay, and I could do the same thing. Okay, is this showing? I could do the same thing with side C, but I really don't want to do that. I just want to show you why this works out that way. Okay, so it's not something that's just pulled out of thin air and somebody decided, hey, this works. It's algebraically provable that B over sine B equals A over sine A. We could do the same thing with C. Okay. And so now let's get to using the law of sines, which is basically a proportion, okay? And so with the law of sines, what I always like to do is I like to find the angle and the side that match up, okay? And so I see that this angle 77, this side 15. Say 15 over sine 77 equals, okay? Now I'm trying to find C. So C is my side length. What angle goes with C? This one, sine 23. So what happens, and I almost did it, is just wrote 23. Make sure you're sine of that angle, okay? And so now we have a proportion that we can solve. Cross multiply, get 15 sine 23 equals c times sine 77. Divide both sides by sine 77. And so now I have a problem doing my calculator. Okay. So 15 times sine 73, close parentheses, oops, nope, it was sine 23, right? Okay, and then I'm going to divide that by sine of 77. I always do that in 2 steps just so I can make sure that I'm doing it right. We get 6.015. The directions say to the nearest hundredth, so we'll see that C is 6.02 to the nearest hundredth. Okay. Number 2, let's try kind of the same type of problem. Here we have the angle 50 and side 11, so that's the completed side. I like to set that up first. Sine of 50. And then I go to what I'm trying to find. I'm trying to find this angle x. Its side is 7. So 7 over sine x. Notice that this is different now. We're trying to find an angle instead of a side, an angle instead of a side. But the process is still the same. Cross multiply. Get 11 times sine x equals 7 times sine 50. And then I want to get x by itself. So first I'm going to divide by 11. Okay, so I get sine x equals 7 sine 50 over 11. Okay, now before I go to my answer, I'm going to see what 7 sine 50 over 11 is. So 7 sine 50. Then divide that by 11. Okay, so I get sine x equals some number, this. Okay, I'll just write this here even though don't stop with that. Okay, now we know to get x by itself, we're going to have to use inverse sine. So in my calculator, I'm going to say second inverse, second answer. Okay. And that gives me 29.17 degrees. X is 29.17. Now the directions say to the nearest tenth, so 29.2 degrees. Alright. Final example here. Given a diagram, triangle FGH. Let's draw that. So we're given a description. Let's draw the diagram. Okay, so triangle FGH doesn't really matter where you label these. In this case, triangles, you can't go wrong. FH is 7. HG is 12. The measure of angle F is 72 degrees. Okay, again, I found my matching pair, so I'll write that 12 over sine 72. Okay, and we want to find the remaining sides and angles. So, first thing I can find is angle G. I'm going to find angle G first, and that's because I have its matching side. So its corresponding side is 7. I'm going to say sine of x. I guess I could call it G, but I'll call it x. Okay, and now we're setting up and solving it just as normal. So 7 sine 72 equals 12 sine x. Okay, I'll divide both sides by 12. In my calculator, I can do 7 sine 72 divided by 12. That gives me 0.554. Okay. Just write this down here so you can see where I'm going or why I'm there. Okay. And then I need to get x away from sine, so I'm going to use inverse sine of what I just got, second answer. And I find that x is 33.69. It says find degree measures to the nearest degree, so I'll say 34 degrees. Okay, the measure of angle G is 34 degrees. Okay, so I can find that. And we said we can find all the missing sides and angles now. Since we know that this is 34 degrees, this is 72 degrees, and the triangle always adds up to 180. 72 plus 34, 180 minus that, I know it's going to be 74. Okay, I can find that angle H is 74 degrees. Okay, so the measure of angle H is my second missing piece, and I can find that without using trig. Now, I will have to return to trig in order to find FG. We'll just call it Y. So again, I'll use this trig function or trig ratio. Sorry, law of sines. Better way to say that. Sine 72 will equal the angle that we know, so sine 74 y. So cross multiply, or in this case I could just say multiply by sine 74. I get 12 times sine 74 over sine 72 equals y. Okay, again, just do this in your calculator. Sine 74 divided by sine 72. And that equals 12.12. It says to the nearest tenth, so 12.1. So FG equals 12.1. Okay? Alright, so that's using the law of sines to find all the missing measures of a triangle. Alright, see ya.